So what we're going to do now is demonstrate how manual muscle testing, you can use different biomechanical strategies and force length strategies to isolate one synergist from another. And we're going to use, as an example, is the biceps long head and isolating the supinator muscle during forearm supination. So essentially we're going to start with the 90-degree elbow bent position here and look at the moment arm of the biceps and angle of pull. So basically we know that the perpendicular distance to the joint center in this case is here, okay, and the angle of pull is 90 degrees. So essentially when we look at the joint, the proximal radial ulnar joint from an axial view, so from the top basically, it looks something like this. So we have the radial head here, we have the tuberosity here, and the axis of rotation would be here. So then if we draw the muscles force vector here, what we know is that the perpendicular component to the forearm of the biceps is going to act superiorly and is going to contribute to supination, or the turning. So this would be lateral is this way, because the medial would be here with the ulna. And then the supinator muscle itself would also contribute, okay, by pulling the shaft of the radius laterally. Okay, so we have the force of the supinator. If we look at their moment arms, it's pretty clear that they both have pretty good moment arms relative to causing forearm supination. The other thing we could start to think about as well in terms of PCSA, the PCSA of the biceps is clearly much larger than the supinator. Okay, so how would you then, if we really wanted to test just the supinator, how would we eliminate the contribution of the biceps using manual muscle testing? Well, so the first thing we can note is that FB doesn't always equal FB perpendicular. Now at 90 it does, so at 90 degrees FB perpendicular equals, right, it's going to equal essentially FB sine 90, because sine 90 equals 1. FB perpendicular equals FB. So essentially you have quite a powerful pull at 90 degrees, and so you really don't even need the supinator because the biceps long head is so strong. But what happens when we extend the elbow? So essentially we have this situation, so we're fully extended elbow. We have the pull of the biceps now is almost parallel to the shaft of the forearm. And so that's FB. So basically FB perpendicular equals FB, so we'll say this is 10 degrees here, it's FB sine 10 degrees. So it's clear that FB perpendicular when the elbow is extended is much less than that when the elbow is 90 degrees. And so we look at the equation, looks something like the model, looks something like this. We draw the radial head again, looking from an axial view. We can put in the tuberosity and then draw the force vectors, force the supinator muscle here, and then for the biceps longus here, so there's the force in the biceps perpendicular. But now we note that the perpendicular force is FB sine 10 degrees. So it's clear that FB perpendicular at 90 is much greater than FB perpendicular at 0 degrees. And so for this reason, one strategy in isolating the supinator muscle would be to test it with the arm fully extended. And that way the contribution of the biceps would be much less, and therefore the maximal test would recruit the supinator muscle much more in terms of loading it. Okay, That's